always mildly annoyed that the first few seconds is always me telling it, no, I don't want you to have the webcam on. It's weird. Anyway, let's do some mini tab. Hey, we're going to talk about confidence intervals of stuff today. And again, this one says for proportions, and it shouldn't because this is everything. So today you'll notice that I have for this video, you'll notice that I have no data. I have all summary stuff. We're going to be doing things using Minitab essentially like a calculator to assist us with stuff. This is a lot of what you're going to see in your homework, so this is an important video to watch. Hope you're ready. Okay, let's talk about candy, because that's where we all want to be. Suppose we're looking at a sample of Reese's Pieces candies, and we found that 109 of them out of 200 were orange. In case you didn't know, even any candy that has multiple colors usually isn't an equal amount of colors in their candy selection. This just makes it look more artful. Most of the people in the world know of M&Ms. The most common color in M&Ms is actually brown, because when they first started selling them, people were convinced they were not chocolate because there were too many colors. That's hilarious. Anyway, so we're going to do a 95% confidence interval for this data. Since this is clearly counting something out of a total, this is going to be categorical data, not quantitative data, because it has no units. So we're going to go and do a proportion to this. I also tell you it's a proportion in the question, but we're going to do the proportion that are orange. I made my husband eat candy and count. It's fun. So I torture him. We're going to go to stat, basic statistics, and then where mouse is going to screw up for fun, and then down to the one proportion. This is where you do confidence intervals for a proportion. You notice that this defaults to, you've got data. I don't. I have a summary. So if we hit this drop down, you'll notice the option for summarize data. That's the one we want. We're going to put in our number of events. 109 interesting thing happens out of 200. And as we should always, let's check our options. Make sure that they're set correctly. So to do this correctly, we need to be set to a 95, which is correct. Ignore that middle one. It just has to be a not equal to. And then we need to change it to the normal approximation mode because that's the one we're going to use. The exact method isn't that different from the normal approximation one. It's just the one that we use in general. They're not that different. It doesn't matter. If you would like to know more, Google it. Yep. Let's hit OK. And hit OK again. And there's our confidence interval. Since the confidence interval is the only part I need, I'm just going to copy it and paste it to my document. Oops, it's wanting to paste it in a weird spot. And I'm done. There's my confidence interval. So notice Minitab does write it as an interval, as you should, rather than that weird long dash form that exists in your textbook for I don't know what freaking reason. That's weird. Anyway, what the frack? So I look at this and I'm like, oh, okay, that's a kind of big range of values. And then you ask yourself, is 50% the percentage of orange candies? Well, 50% is in the interval, so it is possible that that is our value of our proportion. So I can't refute this with what I've got. In fact, I'm pretty confident that it's one of the possibilities. So my interval says this is perfectly possible. It could be 50%. It doesn't refute it at all. Now, if my interval, if I was asking about 80%, you could say, oh yeah, I'm very certain that's not part of it. In fact, I'm 95% confident that that's not a possible value because it lies outside my interval. So my interval says that my parameter, or my population proportion, or the percentage of all Reese's Pieces that are orange, is somewhere between 47.5986% and 61.4014%. God, I sound like a robot. And 50% is in there. It's between those two values. So it's perfectly possible as the range of values contains 50%. Remember, it's any value in the interval that possibly is it. So yeah, it's reasonable. It is possible. 50% is it. I included this question because this is the kind of thing we're going to get up to next week. We're going to ask, is this a reasonable value? And then we'll actually have to answer that question, which is not the easiest to do. Oh my God, I'm so sorry. I'm having a day with this mouse. Oh, I bet you it's low on batteries. Anyway, let's move on to number 2. So number 2 asks you to use the t-table to find some critical values. I'm not going to do that. I'm going to show you how Minitab does some t-values. You'll notice for A, B, C, and D, I gave you the degrees of freedom, not the sample size. So I didn't give you N, I gave you DF. So in particular for A, since the DF is 20, that tells us that N has to be 21, since the degrees of freedom is 1 less than the size of your sample. So to do this, actually, we use graph probability distribution plot. View probability. Are you surprised? You shouldn't be. 95% confidence is actually a probability. All right, so I'm not using the normal, I'm using t. My degrees of freedom is 20. I'm going to go over to shaded area now. And I want to have 95% level of confidence, which means 95% in the middle, which means lying equally on each side outside of this in the tails will be 5%. So I want to put 5% in both tails. So I'm going to select both tails with 0.05 and hit OK. And then there's my t value. So it appears that my value of t is 2.086. That's nowhere near 0. Sorry. I think I'm funny and I'm not. It's okay. Cat sounds while I stall and type things. Anyway, so there's a value of t. Let's do this again. So since I'm just going to be repeating the same process but with a slightly different level of confidence, I'm just going to hit the edit less dialog box. I'm going to go over to shaded area since my DF remains the same. And now since I want to do 99%, I'm going to change the tail to have 1% in it since they need to add to 100. All right. And notice that it significantly increases my t. Well, I don't know if it's significant. I'd have to do a test to determine that. Anyway, so the point is it goes up and I'm more confident. That makes sense. That's what we expect to have happen. My number of standard deviations away has increased because I'm making a wider interval. Alrighty, let's try it again with a lower level of confidence and higher degrees of freedom to see what happens. So I'm changing two at once. So I'm going to change my degrees of freedom to 32. So this would be a sample of size 33. I'm going to go over to shaded area. And now I want 90% in the middle, which means I want 10% on the edges. So I want 0.10 instead of 0.01. And then I'm going to hit OK. Remember, if I go too fast, you can rewind this. Now that t value is smaller. 694. The other thing I want to do, if I can do this, hold on a second. I'm going to shrink my Word document. Ignore that. It's my husband with Godzilla. No. I want to show you how these look next to each other. Because, it's hard to see with 20 versus 32. Let me do one thing really quick. I want to show you something. Let's do one like 8. Because that'll look really different. There we go. That's not what I want. Yeah, yell into the mic. Good job. What I want you to see is how they have a different... What is my life? There's that one. Awesome. I want this one. I want you to see that they look different. So this one in particular is much wider in the middle than the other one. If you kind of line up their bottoms together, you can see it, I think. Yeah, this one's a little narrower than that one. Yeah, this is hard to see. They look different. Just yell the answer at them. That should work really well. I'm so glad he can't see what I'm doing right now. Oh, this is just the worst video I've ever done. Nope. Okay, yep. I'm done blaming it on the mouse. It's definitely the user. Okay, let's do this last one really quick before I lose my mind. Alright, T, let's do 1000, because T1000 is the Terminator. And then we're going to go over to shaded area. I'm not kidding, that's how I picked that. And I'm going to change it to 5%. So notice that D has the same confidence level as A, but my sample sizes are significantly different. Oh, I should have known that was coming and compared it to this one. Because this one, yeah, look how fat that middle is. That's totally different looking. That's the one I should have done this with. Let's see. I want that one. And this one. Nope, that's the one I just did. Look at that. They look so different. Do you see it now? Look how much wider that dude is in the middle versus this one. T is different for every degree of freedom. Anyway, so my T value is 2.330. Now I'm hoping you notice that I'm just using the positive one. It's because when you're using T, it always ends up with a negative twin. It's symmetric. It's literally the same value but negative. And if we're doing confidence intervals, we're adding and subtracting. So if you add and subtract a negative instead of add and subtract a positive, Adding a negative is the same as subtracting, and subtracting a negative is the same as adding. You end up with the exact same values. It makes absolutely no difference which t you use. So we usually just list the positive one out of laziness because it's less to write, and I'm not kidding. Okay, why can't I get this to work today? You've now seen all of my internets. Enjoy. Okay, let's do some coffee. So, a coffee and machine in the break room dispenses coffee into paper cups. The machine is supposed to dispense 10 ounces of coffee, but the amount varies from cup to cup, and you collect a random sample of 20 cups with a mean of 9.845 ounces. A naive person is going to look at that and say, oh, that's close enough to 10, I'm done. No, 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 no. Don't forget, samples vary, and there's such a thing as sampling error. So we should investigate. Now, the standard deviation is 1.99. We're going to create ourselves a confidence interval for the mean. So let's start off with, hey, what's the sample mean? 9.845. What's the standard error? Be careful, that's not the standard deviation. This is the spread of the sampling distribution. So that's going to be 0.199 divided by the square root of 20. In case you've ever wanted to know, SQRT is the Unicode code that almost every single computer programming language uses for square root. Now I'm going to grab my calculator and make it do this. Now this is kind of hard to do on the Microsoft calculator. So there's a reason I'm doing this. So what I want to do is I want to do 20, then square root it, then put it in the denominator and multiply it by 0.199. Did you follow that? Because it's horrible. Don't worry, I've got a better solution to this if you hate the Microsoft calculator, because that was scary. And I hope you aren't. Oh, I hope you're not scared. I hate myself. Okay, here we go. So there's that. That's fun. Now it asks us for degrees of freedom. Well, there were 10 items in our sample. Oh, no, wait. There were 10 ounces of coffee. There were 20 cups of coffee. So there is 19 in here. Perfect. All right, now find the margin of error. Ugh, this is where I'm getting annoyed. Let's just do the confidence interval. So I'm going to go to Stat, Basic Statistics, and this is going to be a one sample t. I know it's a t because I do not know the standard deviation of the population. I know the standard deviation of a sample because the 1.99 came from the 20 cups, not the whole population. I'd have to sample every single cup that ever came out of the machine to do that. That sounds impossible. All right, so once again, we're meted with this drop-down window, and we're going to change it to summarize data. My sample size is 20. My mean is at 9.845. My standard deviation is 0.199. All right, let's check our options. 95% looking good. Alternative hypothesis doesn't really matter as long as it's not equal to, will be good. Let's hit our OKs. All right, so I'm going to actually copy this over right down here and make it a little bigger so it's easier for you to see because I want to grab the whole thing. It's a little small. Ugh, why did I paste it that way? That's better-ish. It's bigger. Anyway, so I'm hoping you notice standard error for the mean. Hey, that's this. So you didn't have to calculate it by hand. It does it for you. So use Minitab. It saves your life, and you don't have to worry about the Microsoft calculator being crazy. Anyway, so here's my confidence interval. I want to use it. So like earlier, to get my margin of error, I'm just going to take the upper part of my confidence interval and subtract my mean. I did that earlier, didn't I? No? Okay, now you're confused. I know I did it in the other video. That's what I'm talking about. So remember, to get a confidence interval, you add and subtract the margin of error. So I take the mean, I add the margin of error, that gives me the upper value. So if I want the margin of error, I can just subtract the mean to get the margin of error. So to get the margin of error easily off of a confidence interval, you just want to take the upper part of the CI and subtract the sample mean. But spell it correctly, otherwise everyone will know you're wrong. So 9.9381 minus 9.845. And that I cannot do in my head. Sorry, peoples. 9.9381. I definitely need to get new batteries for stuff, because I usually have a 10 key I use for this, and I do not know where it is or if it works. Ooh, that's kind of small. Or actually, no, it's not. It's kind of big. It's almost 10%. That's not good. Oh, no, wait. I'm thinking of proportions. This isn't a proportion. That's small. That's good. That's less than 0.09 ounces. Or, no, slightly more than that. Yeah, that's not bad. It's not too bad. Anyway. So there's my margin of error. Alternatively, what you could have done is taken the standard error for the mean we calculated right here and the degrees of freedom and used what we did in number 2 to find the t-value that goes with it, multiplied the t-value times this to get the margin of error. So there's another way for you to do it, in case you were wondering why I bothered with the t nonsense earlier. So there's margin of error. Create a confidence interval. We did that. That's right here. Give an interpretation. So I looked at this and I was like, oh no. Take a look at the coffee. Is that 10 ounces? It is not. We are 95% confident that somebody is gypping us because we got less coffee than what we should be. That the mean volume amount of coffee dispensed by the machine is between 9.7519 and 9.9381 ounces. So it's less than 10. And that's a problem because the machine is supposed to make 10 ounces of coffee and it doesn't. So if you were the person who was in charge of this machine, you should clean it, get it recalibrated. It's clearly not working. Yeah, so keep in mind this is an average, which means some of the cups are less than this, and some of them are more, but clearly my average is not close to 10, so that's a bit of a problem. So in particular, if you've ever got any spare time on your hands, the next time you're at the grocery store, pick something that's in a clear bottle and comes in a pack, and set it down on something kind of flat, like take a pack of Coke. Because it's a dark liquid, you can easily see where the tops are versus the clear bottle. And you'll notice that a lot of the bottles have higher values, some of them have lower values, and it evens out. When they are measuring whether or not a machine is properly filling, they will stack a set of them, like 8, 9, 12, or 16, and then measure the average weight to get the amount of filling. And they'll say, yeah, on average, it's 20 ounces. Is it really 20 ounces? Probably not. Some of them are higher, some of them are lower. But on average, it might be. Another fun fact, the first webcam ever for the internet was set up to see if there was coffee in the coffee pot at a university study area. So the nerds who were working in the lab could see if there was coffee for them to go get or if they'd have to go upstairs and make a pot. Born of laziness, the webcam. Fun facts. I forget which university it was at. I think it was Harvard. Don't quote me on that. Have a good day.